Good day. This is our fourth video in our series on momentum. Now let's quickly have a look at yesterday's homework where you had to represent change in momentum as a vector. So we're back with our tennis ball sum where we can calculate our initial momentum as 1.5 kilograms meters per second to the right. We calculate our final momentum, which is the mass times the final velocity, as 1.8 kilogram to the left. No, not kilogram to the left, 1.8 kilogram meters per second to the left. And then I can also calculate my my change in momentum as final momentum minus initial momentum. And when I did the calculation previously, I found that to be 3.3 kilogram meters per second to the left. So there is my three vectors. I manipulate my equation on change in momentum so that I have change in momentum plus initial momentum. As soon as I have addition sum there, I can write these two vectors as head to tail. So let's start with a change in momentum, which is 3.3, and with a head of the change in momentum, there I must start with my initial momentum, which is the green arrow, and put those two head to tail. And then in order to get the resultant of those two, I start with the tail of the first and end with the head of the last, and that will give me my resultant. So there is my proper vector representation. Okay, let's look at this one, which has the zero momentum for the final momentum as an example. Okay, my initial momentum, I have 10,000 kilogram meters per second to the right. My final momentum I'm going to represent by a single dot, because in maths a dot usually do not have any dimension, it doesn't have a length. And then I know my final momentum is equal to my change in momentum is equal to my final momentum minus my initial momentum. So if I represent this, I first manipulate my equation. So I start with my change in momentum. There we go, which is the orange arrow. And to that head to tail, I had to add my initial momentum. Those two are the same size, so you can see the resultant that they have is actually 0. And that is the last one that I add, and the 0 I represent with a dot. Okay, let's start with a new concept for today. You must write Newton's second law in terms of momentum. Now let me show you this step by step. Last year, when you did Newton's second law, you formulated this equation. F net is equal to the mass times the acceleration. But in grade 10, you learned that acceleration is change in velocity divided by change in time. Change in time, we represent, or we call that in maths, or the correct proper language for that is tempo of. So acceleration was the tempo of the change of velocity. That's the words that I use when I read this equation. Okay, now change of, we just looked at that when we looked at the momentum as well. It's just the final velocity minus the initial velocity. So if I take this equation and I substitute that into my acceleration equation, then I find that acceleration is v final velocity minus v initial velocity divided by delta t. So I have this equation. So now I can take my acceleration here and just substitute it into that equation so that I get F net is equal to m, and there is now my new formulation of A from this equation. Okay, so let's simplify and get rid of this bracket. I get F net equals m Fv final minus m velocity initial on delta t. But you have come across mv final and mv initial. This mv final is just my final momentum. So I can rewrite this equation as F net is equal to P final minus P initial divided by delta t. And P final minus P initial is not a new concept to you either. You've learned that that is change in momentum. So if net is just equal to change in momentum divided by change in time. I repeat again, change in time, the proper scientific language to state that is to call it a tempo. So if I take this final equation and I put that into words for Newton's second law in terms of momentum, it would read as follows. The resultant force acting on an object, is equal to the tempo of change of momentum in the direction of the resultant force acting on the object. This is the proper wording for Newton's second law in terms of momentum, and they love to ask this in exam. So make sure that you are able to write this down. Okay, now I'm going to give you an opportunity in the worksheet to quickly see if you can write down this proof. Although they never ask for the proof showing that change in momentum is equal to change, or the tempo of change of momentum is equal to the net force, it is good to have a good understanding and remember where this comes from. That physics is logic. It's not just a bunch of laws that people made up. Okay, so quickly have a look at the worksheet before we continue with our next video. Good luck.